At the beginning of 2020, the world has already produced a mind-boggling 40 zettabytes of data. To put it into perspective, this amount of data is 40 times bigger than the number of stars in the observable universe. On average, every human created at least 1.7 megabytes of data every second in 2020. This astronomical amount of data generated every single day from social media, video sharing, Google searches, and emails are expected to rise in the coming years. Add to that, the wide adoption of IoT devices created a tsunami of data streams flooding the cloud. By 2025, the cloud will process and store over 200 zettabytes of data. The massive data flow and processing will definitely create a huge strain on the cloud infrastructures. As a result of this, latency and bandwidth shortages will exacerbate. In combating this ever-growing problem, one solution, in particular, has gained momentum in recent years and showed promising results. Enter edge computing, the future of data processing and management topology. Greetings, dear viewers, welcome to another episode of Cream Rises Up. In this video, we will explore a bit about edge computing and show you how it will impact the constant digitization of our planet in the years ahead. Sit tight and enjoy the program as we unravel the nuts and bolts of edge computing. At a glance, edge computing provides a platform for closer proximity between data origin and processing activity, meaning all the computation and data storage takes place closer to the source or the devices where it's originated. This gives us a performance boost by reducing the latency and bandwidth requirement. Moreover, companies can save a ton of money by processing the data locally, reducing their reliance on enterprise cloud infrastructures. The advent of edge computing came at a time when IoT devices flooded households all over the world and tremendously overloaded the cloud. And many IoT devices generate enormous amounts of data during the course of their operations. The endless streams of live camera footage is generated from all over the world, and smart home appliances that send and receive network packets enormously burden the cloud providers. As a result of this, quality suffered due to latency, and bandwidth costs skyrocketed. Devices and services installed at the edge can alleviate this problem by sharing computation and storage tasks originally allotted to the cloud while being close to the people that produce the data. For instance, an edge computing appliance can process data from an edge device and then send only the relevant data back through the cloud. This plays a major role in reducing the bandwidth needs. Edge devices can be a laptop, a security camera we installed at home, a smart microwave oven, or the smartphones that we use every day. The large amount of data generated every day from billions of smart devices are not exploited or used to aid decision-making. One interesting study from McKinsey & Company conducted in 2015 indicated that an offshore oil rig generates data from 30,000 sensors, but less than 1% of that data found its way back to decision makers. That is a lot of wasted bits of data. The untapped data which comes from connected devices need careful massaging and extrapolation. Edge computing fills this void by harnessing the influx of in-device computing capability and giving decision makers comprehensive analytical data in real time. A well-thought-out edge computing design should address management complexities, network security risks, and the limitations of latency and bandwidth. The autonomous nature of edge is also essential in eliminating the reliance on cloud infrastructures and enables us to access our data on-premise 24/7. There are plenty of scenarios that we can employ edge computing. Some of the common ones include predictive maintenance, patient monitoring, smart grids, traffic management, and remote monitoring of assets. So, let's look at them one by one. One of the areas where edge computing is becoming a staple is in the manufacturing sector. Manufacturers want to maintain the health of their equipment for as long as possible, and one of the best ways to realize this is by conducting predictive maintenance using real-time collection and analysis of machine operation data. Here, edge computing plays a major role in bringing the processing and storage of data closer to the equipment. IoT sensors monitor the health of the machines and provide real-time data with negligible latency through the aid of edge computing devices. Smart grids are also benefiting from the emergence of edge computing. The way smart grids work is by facilitating two-way electricity and data flow. This setup ensures the effective monitoring of energy usage in order to optimize power distribution efficiency. It is achieved by installing smart sensors and IoT devices across the grid. Edge computing facilitates data flow and real-time analytics to be used on a decentralized or distributed energy architecture. It can enable companies to make an educated decision on when to use their heavy-duty pieces of machinery during peak times of electricity demand. This greatly enhances power usage efficiency and reduces the burden for the entire electricity grid. Hospitals these days use many types of equipment for patient care, including glucose monitors, CT scan machines, and heartbeat monitors. These hospital machines generate lots of data, and in many cases they are either not connected or send all their data to third-party cloud providers where security is a major concern. A hospital that utilizes Edge can process data locally to maintain data privacy. Additionally, doctors and practitioners can access their patients' behaviors and trends in real time to make quick decisions. The speed by which Edge architectures deliver these highly valuable patient data can be the difference between life and death. We know how hectic city traffic flow can be, and managing its massive data output is paramount. Through the use of smart sensors and edge computing, we can give speedy responses for routine traffic jamming problems, recommend the fastest routes, and minimize congestions. Another area that edge computing plays a major role is remote asset monitoring. For instance, the oil and gas industry needs an effective remote asset monitoring system because most plants in this industry are located in remote areas. Failure to do so can be catastrophic. Managing these assets through edge computing can be a godsend in terms of preventing disasters. Real-time data from sensors and edge gateways is an indispensable asset for the oil and gas industry. The advent of containers and orchestration platforms such as Kubernetes is playing a massive role in the adoption of edge computing. With Kubernetes, companies can run containers at the edge in a way that maximizes resources and create a synergistic environment for DevOps teams as these organizations gulp and analyze data close to where the action happens. It will be interesting to see as more and more companies adopt container-driven edge platforms in the years to come. It is essential to understand that edge and cloud computing are different, not interchangeable with one another. Whether a company chooses edge or cloud depends on its requirement and use cases. While the cloud is mostly used to process non-time sensitive data, the edge on the other hand is essential in an environment where timely execution of tasks is critical. Besides ensuring low-latency connection, the edge is also essential in providing the necessary computing and storage capacity needed for remote areas where the cloud can't reach. We have to realize that it's not either-or debate when it comes to edge versus cloud. Rather, they provide more computing options for your organization's needs in unison. There are plenty of companies out there who chose to use a hybrid solution. This implicates that we can harness the strength of both cloud and edge computing to establish a more robust system-wide infrastructure. So, what do you think about the potential of edge computing and its future prospects in the world of data capturing, computing, and delivery? Please drop your comments and let us know your opinions. Finally, do not forget to subscribe to our channel. And if you like our content, give us a thumbs up also. Thanks for tuning in and cheers.